right, so we are going to be doing another topic with curve sketching, and so we're going to be looking at asymptotes. Now, today's lesson, we're going to be looking at 3 different types of asymptotes, so vertical, horizontal, and oblique. And instead of doing one long video, I'm actually going to break this into 3 sections. So part 1 will just be on vertical asymptotes, part 2 on horizontal, and then part 3 on oblique. So rather than having to pinpoint sections of the video, you can just open up the video that you need. All right, so today we're going to look at vertical asymptotes. Now, we've looked at vertical asymptotes previously in the course, so some of this you're going to find should be review, but we're still going to talk about it as if it's a new concept. So when we're looking at vertical asymptotes, we're just dealing with rational functions, and in fact, for most of what we're doing with asymptotes, we're looking just at rational functions. And when we're looking at vertical asymptotes, you'll often see me denote it as VA, and we're looking at a vertical line, so the equation will be x equals a. So if you remember, vertical asymptotes occur when the function is undefined. And so when we're looking at a rational function, we're really looking at the denominator and looking at what values of x make the function undefined. And so the y values approach positive or negative infinity as you get close to a vertical asymptote. And so we would expect then that the limit of a function at a restriction would be plus or minus infinity, or it wouldn't exist. In other words, we're talking about one-sided limits here. So because of one-sided limits. So if we go just based on that information, that when I figure out my NPVs, those are my restrictions, therefore those are my asymptotes, this would be our assumption, that the limit would be equal to plus or minus infinity, or it wouldn't exist. And so we want to check if this is the case. So here's 2 different examples of rational functions, where in both cases the NPV is x equals 3. So in this case, x cannot equal 3. And for this function, x cannot equal 3. Well, let's see if they both have an asymptote at x equals 3. Well, if I graph this first one, I'm still going to have my asymptote at x, or I'm going to have a line here at x equals 3. And we're not going to get into the curve sketching part yet. If I were to actually graph this, maybe look like this. There's going to come a point by the end of the asymptotes lessons where you're going to be able to do a lot of this on your own without having to plug it into a calculator or do a table of values. Now, if we look at x squared minus x minus 6 over x minus 3, I can factor the top, and that would give me y equals x minus 3 times x plus 2 all over x minus 3. And by factoring, we end up eliminating that number on the bottom. So, or that term on the bottom. So we're left with y equals x plus 2. But we still have a restriction of x cannot be 3. So in this case, this one would actually look like a line, a straight line. But instead of having a complete straight line there, we'd have our arrows on the ends of the function. We would still go through y-intercept here of 2 because the function is y equals x plus 2. But we're actually going to have a point of discontinuity. So right here, there's actually going to be a hole in the graph. And so it's going to happen when x equals 3. And if we plug in y equals 3 plus 2, we get 5. So this point of discontinuity happens at 3, 5. So there's no vertical asymptote, but there is a point of discontinuity at x equals 3. So if our rational function can be reduced, even if we have an NPV, that doesn't necessarily mean that we'll have an asymptote. So if any of the following are true and a is an NPV, then we're going to have a vertical asymptote. So if the limit of a function as x approaches a has a value of plus or minus infinity, or if we're dealing with one-sided limits as in I approach from the left or I approach from the right, I have a value of plus or minus infinity, then we will have an asymptote, and that asymptote again is x equals a. If x approaches a, or if we take the limit of a function as x approaches a and we actually have a value, so it's not plus or minus infinity, then that means we have a point of discontinuity. at that point, comma L. All right, so that's just basically sort of the definitions and the theory behind vertical asymptotes, but it's going to be better once we get into looking at some examples and breaking it down. As you're going through these lessons, you may want to spend just one day on vertical asymptotes. Horizontal and slant are a little bit quicker to go through, so you may choose to do those in one day. All right, so example 1 here, it says find any vertical asymptotes for the following functions. So we're going to just start off with the basics. We have an NPV at x equals 0, so x cannot be 0. And when we're looking at our asymptotes, we're always going to be looking at both the left-hand limit and the right-hand limit. So we're doing one-sided limits here. So if I look just at the limit as x approaches 0, so the limit as x approaches 0 of 1 over x squared, I have infinity. Now, if I want to look at these specific left-hand and right-hand limits, I've got the limit of 1 over x squared as x approaches 0 from the left. Well, if I could plug in, if you remember from earlier in the units, we used to plug in values to kind of figure out what the answer is. I'm going to just describe what that value is. So if I were to plug in any number on the left-hand side of 0, in other words, any negative number here, I'm going to have a negative number that's then squared. And so 1 over a negative number squared is just a positive number. So 1 over a positive number, 1 over a positive number is going to be approaching infinity. Okay. Now, if I look at the limits as x approaches 0 from the right-hand side, we're going to have 1 over x squared. If I plug in any numbers from the right-hand side of 0, those are going to be positive numbers. And so 1 over a positive number squared is still 1 over a positive number. And so my limit is infinity. So because the left-hand limit and the right-hand limit are the same, we have the limit as x approaches 0 is infinity. So that means that I have an asymptote at x equals 0. So we draw our asymptote at x equals 0. And this particular graph, it's coming from the right, is approaching here. And from the left is approaching there. Now that's not the greatest graph. We'll try to redraw it here quickly. So we have an asymptote right here. That's happening at x equals 0. And if I sketch my curve, the graph is coming up here. It's approaching, and then it's falling down this way. And again, our asymptote happens at x equals 0. So we have a vertical asymptote at x equals 0. All right, we'll just keep looking at some more examples. The rest of this is all examples varying from sort of the simple to getting a little bit more complex. So hopefully I can give you enough examples that you've got a really good idea of how to determine your vertical asymptotes. So here, x cannot equal 0 again. We're going to look at our left-hand limit. So the limit as x approaches 0 from the left of negative 1 over x to the 4th. Well, the negative 1 is still just negative 1. Now, any values approaching from the left, approaching 0 from the left, are going to be negative. And so any negative value to the 4th is going to be a positive value. So negative 1 over a positive value, so negative 1 over a positive value is going to be a negative infinity. So that means the graph is going to be negative 1 over some positive number. No matter what positive number I put in there, even if I put a really large positive number in there, I'm still approaching negative infinity. And so then if we look at the right-hand limit, so x approaching 0 from the right-hand side, negative 1 over x to the 4th. Well, any values approaching 0 from the right-hand side are positive numbers. So it's going to be some positive number to the 4th, which is still -1 over a positive number, which means we're again approaching negative infinity. So our asymptote will happen again at x equals 0. And if we sketch our graph, we're going to be approaching negative infinity. Now you again might be asking, well, how do I know exactly how to draw this graph right now? We could do this with a table of values. Right now we're just doing a quick sketch and the focus is on the asymptote, but we will get into why I'm curving them the way I am and so on. Some of that we've talked about in previous topics. So VA is occurring at x equals 0. All right, now if we have f of x equals 1 over x, again, we have a restriction that x cannot be 0. And if we look at approaching 0 from the left, so as x approaches 0 from the left of 1 over x, any value in there is going to be negative, so 1 over a negative number means we're approaching negative infinity. Now the limit as x approaches from the right is going to be, oh, sorry, don't want that negative there. 1 over x, we're going to have 1 over a positive value, which means it's going to be approaching positive infinity. And so in this graph, we've still got our asymptote at 0. But our left and right hand limits are different. So this time as we're drawing the graph, as we're approaching 0 from the left, we're approaching negative infinity. Oh. Let's try that again. We're approaching negative infinity. And as we're approaching from the right, we're approaching positive infinity. So while we would say there's no limit at that point, or the limit does not exist, we still have an asymptote. So if we were to make some conclusions here, we were to write out a rule. If the limit of the function as x approaches a from the positive, or sort of the right-hand side or the left-hand side, if that is plus or minus infinity, then we have a vertical asymptote at x equals a. So in the above example, we have a vertical asymptote at x equals 0. Okay, so we're going to look at a couple more examples here, and these ones will get a little bit more complex, but the concept is still the same. We're still looking at the left hand and the right hand limits, and we're going to do a quick sketch. Now, when we do these sketches, I'm not going to sketch the entire graph. We're just going to sketch the end behavior based on the asymptotes. So the question here says to find the limit or the value of the limit and then give a partial sketch. So we're looking at the limit as x approaches 6. So we can break this down using our limit laws. The limit as x approaches 6 of 2 minus the limit as x approaches 6 of 5 over x minus 6 squared. Well, the limit of 2 as x approaches 6 is just 2. So all the way through, we're just going to have 2 here. Now, when I look at approaching from here from the left-hand side, or sorry, when I'm looking at the limit here, I'm really just going to have to worry about the second part of the term because this part here is 2. Now, if I were to plug in 6 here, if I were to plug in any number here that's approaching 6, I'm going to plug in 6, and that's going to give me 5 over any number approaching 6. So I don't know, we'll choose like 4. So, or we can go really small and go like -2 minus 6. Notice I can't plug in 6 minus 6 because that's going to be an asymptote. But if I plug in some value there, whatever I plug in, when I square it, I'm going to get a positive. No matter what I get, I'm going to have a positive here. So 2 minus 5 over some positive number. Well, 5 over some positive number is leading us towards infinity. So my limit is going to be 2 minus infinity. Well, 2 minus infinity means my limit ultimately is going to be negative infinity. And so because I have a limit of negative infinity, going back to our last rule, that means I have an asymptote at x equals 6. And so if I draw my asymptote here at x equals 6, I know that my graph on both sides, because the limit is negative infinity, on both sides, my graph will be approaching negative infinity. All right, so more often than being asked just to find the limit, because we've done that in previous units, I'm going to be giving you an equation and asking you to find the vertical asymptote and then do a quick sketch. And so for the first question here, we have f of x equals x minus 4 over x minus 2. And so our NPV is x cannot be 2. And if we look at the left-hand limit, so the limit as x approaches 2 from the left, again, I'm not going to plug in specific numbers. We're just going to talk about sort of the theory behind it. But as I approach 2 from the left-hand side, on the top there, I'm going to have 2 minus 4, which is negative 2, or basically we're going to have a negative number on top. No matter what number I plug in from the left of 2, that negative number minus 4 is still going to be a negative number. And on the bottom, any negative number minus 2 is still going to be negative. So the limit of a negative over a negative, we're going to end up with a positive. And so our limit is going to be infinity. Now, if I look at the limit as x approaches 2 from the right-hand side, that means I'm picking any numbers that are bigger than 2. Well, any number bigger than 2 minus 4, any number bigger than 2 minus 4, as we're approaching 2, then we're looking at like 2.0001, 2.000001. But as we take those numbers and we subtract 4, we're still going to have a negative number on top. And on the bottom, we're also going to have a negative, we're going to have a positive number too. So if we take 2.001 or 2.00001 and subtract 2, we're going to end up with a positive value. And so if we take a negative and divide by a positive, we're going to be approaching negative infinity. And so my asymptote is going to happen at x equals 2. So I've got to have a VA at x equals 2. But my end behaviors, as I approach 2 from the left-hand side, my graph is going to be approaching positive infinity. So that means it's going to be up here. And approaching from the right, my graph is going to be pointing downwards. So we're not sketching the whole graph. We're just looking at the end behavior. All right, next example here, we've got f of x equals x over x squared minus 4x. So again, we're going to be looking at the limits here. Before we do that, though, we can factor the denominator. And so if we factor the denominator, we've got x times x minus 4. That means our NPVs are x cannot be 0 and x cannot be 4. And so as we take a look at this, if we look at the limit as x approaches 0, because as I do this, my x's are going to cancel out. So that means I'm going to have either a point of discontinuity or I'm going to have a point of discontinuity. So if I take a look of my limit of my function as x approaches 0, okay, because they've canceled out, I know I've got a point of discontinuity. If I substitute that in, I'm going to have 1 over 0 minus 4, which is negative 1/4. So I'm going to have a point of discontinuity at 0, and it's approaching negative 1/4. So point of discontinuity right there. All right, so let's look at the other part that hasn't canceled out. We're going to have, when this is reduced, we end up with a function that is 1 over x minus 4. And so we're going to have to look at the limit from both the left-hand side and the right-hand side. And so the limit as x approaches 4 from the left-hand side gives us 1 over x, or so we've got 1 over x minus 4. Well, if I take any numbers to the left of 4, again, think as we get closer and closer, we're going to have like smaller and smaller numbers getting close to 4. So negative 4.0001, negative 4.000001, and so on. But if we plug in those numbers, we're going to have a negative number on the bottom. So it's going to be 1 over some negative number. And so that means we're going to have negative infinity. If I take the limit as x approaches 4 from the right-hand side, again, picture we're approaching 4. We're approaching 4 here from the right-hand side, so we're going to have like 4.0001, 4.000001, and so on. We are going to have 1 over a positive number, and that will give us a positive. Now, I think I just caught a mistake here if I had said it wrong. When I was looking at the x minus 4, I was thinking negatives. So when we're looking at numbers that are approaching 4 from the left, we're looking at like 3.999, 3.99999. So if I had confused you in that part, I apologize. All right, so we have an asymptote here happening at x equals 4. And so we'll draw our asymptote in. Got a graph at x equals 4. And as we're approaching 4 from the right-hand side, our graph is approaching infinity. And so our graph will be approaching infinity this way. Oop. Let's try that again. The graph will be approaching infinity. And as I'm approaching 4 from the left, my graph is approaching negative infinity. So I've got to have an asymptote, or a vertical asymptote, at x equals 4. And I'm going to have a point of discontinuity at x equals negative 1/4. Or sorry, at x equals 0, 0, negative 1/4. All right, we're going to take a look at one last example. This one's a little bit more complex. And then that will be the end of the vertical asymptotes. And at that point, I would suggest that you do a little bit of practice first before moving on to the other asymptotes. Vertical asymptotes is probably the one that involves the most amount of work and probably needs the most practice. All right, so we've got f of x equals 6x cubed over x squared plus 4x plus 3. And so again, the first thing we're going to do is we're going to take and factor this. So we're going to have 6x cubed all over x plus 3 and x plus 1. So that means we have NPVs at x equals negative 3 and x equals negative 1. Nothing cancels out, so that means we're going to have to consider the left-hand and right-hand limits for both of those restrictions. So let's start off with negative 3. So as we approach the function, as the function approaches negative 3 from the left, okay, we consider what numbers we're going to have on the top and the bottom. So if I take any number that's close to negative 3 on the left-hand side and I cube it, it's still going to be negative. And when I multiply by 6, it's still going to be negative. So this number on top is going to be a negative number. Now, if I take a negative number that's really close to 3 on the left-hand side and add 3, I'm going to have a negative number. I'll have some small negative number. Now, it doesn't really matter whether it's large or small at this point. That's just, it just matters that it's negative. Now, if I take some negative number that's close to 3 on the left-hand side and I add it to 1, I'm also going to have a negative number. So then we can just go back to our junior high rules about multiplying positives and negatives. So on the top, I have a negative number. And I'm dividing by negative times negative is a positive. So I have a negative number being divided by a positive number. That gives me a negative. So this one will be approaching negative infinity. If I take a look at the limit as x approaches 3 from the right-hand side, on the top, again, I'm still going to have a negative number. Because the negative cubed and then multiplying by 6 is still going to be negative. On the bottom, if I take a number that's on the right-hand side of -3 and add it to 3, it's going to become positive. It'll be a small positive number. And if I take a number to the right-hand side of -3 and add it to the 1, it's still going to be negative. And so now this time we're going to have a negative divided by positive times negative is negative, and a negative divided by a negative is positive. So as x is approaching 3 from the left-hand side, our graph or our function is approaching negative infinity. As we approach from the right-hand side, we're approaching positive infinity. All right, so now we're going to look at the left-hand and right-hand limits for -1. So exact same idea. X approaches -1 from the left. We're going to have a negative number on top. And we're going to have a positive number. And then we'll also have a small negative here. Now, again, the small part isn't important so much as the positive or negative. And so we're going to have a negative on top. And positive times negative is negative. And so a negative divided by a negative is a positive infinity. If we're approaching the function from the right, so the limit as x approaches -1 from the right-hand side, our top number is still negative. When I plug in a number from the right of -1, that's going to be positive, and this one will be a small positive number. So negative divided by a positive will give me a negative infinity. And so all of these have limits of plus or minus infinity. So that means I have vertical asymptotes. And those vertical asymptotes are going to happen at x equals -1 and x equals -3. So I'll start by drawing those asymptotes in. So I've got an asymptote here at -1. I've got at -3. I've got an asymptote here at -1. And then from there, I'm going to look at my end behaviors. And so as the graph is approaching -3 from the left, the graph is approaching negative infinity. So that means it's going to be somewhere down here, preferably a straight line. And then as we're approaching 3 from the right, it's going to be a positive infinity. As we are approaching -1 from the left, we're approaching positive infinity. So that means the graph here is also going to be opening up. And then as we're approaching -1 from the right, the graph is approaching negative infinity. And so if I were just to fix up that one right there, my graph is going to be moving downwards at this point and approaching the asymptote, upwards, upwards, and then downwards. So again, we're just looking at some of those end behaviors. Now, if you wanted to see what this graph looked like, you could certainly graph it on your calculator, or you can take a look at this one here. So that's what the graph would look like. And again, if you notice, we've got an asymptote at x equals -1, and we've got a vertical asymptote at x equals -3. Now, this graph has other asymptotes. It looks like there's an oblique asymptote. We'll get into that in another lesson. All right, so this is the vertical asymptotes portion. I would suggest doing some practice questions, and then I will be posting the horizontal video and the slant video before the end of the day. All right, thanks a lot, guys. Have a great day.